6.4 is the tower quality control form. Now, there are a lot of steps for the towers, and this is where the expertise of the masons really comes into play. Now, the first step that requires a photo is going to be step 3, and there'll be 2 photos during step 3. First, we want to get photo D1 left and right, which is the 20 centimeter brick base constructed with the reinforcing cage placed inside it and 7.5 centimeters of clearance or clear cover between the cage and the base, or what is below those bricks. And you can do this by putting or stacking that reinforcing cage on 4 bricks to hold it up to get cast into the structural concrete tower columns. Then we'll take our second photo, D2, left and right. When we've filled that brick base with concrete, just the 20 centimeter brick base, and completely embedded the lower part of the reinforcing cage. Now in step 4, we'll take photo D3L and D3R, which is constructing the first 120 centimeter of towers, ensuring 7.5 centimeter of clearance for the reinforcing cage. So this means actually building out the brick formwork around that reinforcing cage and then confirming when you get to 120 centimeters tall of bricks from the base of the top of the tier below that we have 7.5 centimeters of clearance of that cage to what is going to be where the top of that part of the tower is. Now, at this point, I'd recommend stopping and waiting at least 24 hours or at least waiting 1 full day to do the next step, which is fill the brick tower with concrete in 20 to 40 centimeter lifts, leaving clearance at the top for the steel wheel. So when we do this, we'll take photos D4 left and right, and note that it says 20 to 40 centimeter lifts. You don't need to really spray paint this inside the tower like the other lifts, but mostly you just want to be careful. You don't want to be having the entire tower filled immediately. That's a lot of hydrostatic pressure from the concrete on pretty fresh brick formwork. We also want to avoid throwing these buckets of concrete into the tower as much as possible, because 1, that is not great for the concrete, and 2, creates more outward force that could potentially lead to failure in the towers. Now, step 5 is to install the handrail cable saddles, so those steel wheels, such that the cable bearing points are 150 centimeters above the top of the tier and level to one another. Now, this is a very small bit of construction in which we'll take photos D5 left and right when we're finished, but it is very finicky. And you're going to want to be going back and forth and double and triple, quadruple checking dimensions to make sure that those steel wheels are not only the correct distance apart from each other widthwise, that they're exactly plumb and straight with the center line, and they're also at the correct height. So this is going to take lots of little bits of tweaking and adjusting, so plan to be very patient on this step. Step 6 is to complete the top of the towers with concrete so that the cable bearing point remains exposed. And this is going to be photo D6L and D6R. Finally, our last photo comes in step 7, where we construct the walkway hump to a height of 110 centimeters below that cable bearing point on the handrail cable, and embed the cable guide bars, where we'll take photos D7 left and right. And now, remember, this is because our cables are always going to be 1.1 meters apart from each other. What's more important than having slight variations in their elevation of that walkway hump is that the cables are exactly relative to each other at all points along the bridge. Now we have a couple things to record also while doing the tower quality control form. We want to record the as-built elevation of the walkway humps above a point of known elevation so we can tie it into the design. And then we want to calculate and record the as-built elevation of the walkway humps above the high water line. We also want to record our as-built delta H by measuring the elevation difference between the walkway humps on the respective towers. And while we do this, we also can record the as-built horizontal distance from bridge centerline to the center of the handrail saddles. What is this going to be? This is our span. And then finally, we can record the as-built vertical distance between the handrail cable bearing point and the walkway cable bearing point. Now you might ask, why are we doing this? Because we just did this in a few steps prior. Why would it be wrong? Well, what can happen is the wheel can start to settle in the concrete over time, or if somebody bumped into it or didn't notice during that process, we want to double check once again that the vertical distance between the cables at this point is good. So there's a lot of things to take photos of, a lot of things to record. Most of the recording, as you may notice, is going to happen after the towers are complete, but it is very important we get this information. So be careful, right when the towers are complete, everybody's going to want to start setting sag and getting ready for that. But remember that, one, we need at least 6 days of curing of that structural concrete before we can hoist the cables, and two, to get all of those QC photos and measurements.